Yeah, so we actually simulate across the spectrum from cells up to schooling fish into human crowds. And one of the challenges is and has always been the computational power that you require when you're actually simulating these individuals. Individuals have to look at each other and see, am I within range to interact with you and so on. And as we start increasing the number of individuals, the computers tend to sort of chug to a stop, and it's very difficult to work. But there's a breakthrough. In the last couple of years, there's been programmable video game cards. So these cards that have been developed for gamers, so they can live in these virtual environments and so on, actually have hundreds of processing cores on them. And this has been an absolute revolution in terms of scientific computing for us. So we're investing heavily in our effort and to try and program all of our simulations on these video game cards. And to give you a sort of a rough impression, we're getting around 300 or more times faster. And if computing gets twice as fast or 3 times as fast, then that's wonderful. But if you can get 300 or 500 times as fast, if what used to take a month now takes you an afternoon, that changes the way we work. And also, because we can harness this vast computational power, we can start asking questions about evolution. We can start simulating these groups of reasonable size with a reasonable resolution and how they interact in space over such long timescales that we can now start having a sort of virtual process of evolution to understand how and why collective behavior has evolved.